Phil, welcome in Amsterdam. You're here for the Making Shift Happen event, Congress, Educational Congress, and you're a special guest because you have been working on bringing computational thinking into the UK curriculum. Can you tell us a bit about how that happened?
Yeah, Erik, really nice to be here, first of all. It all came about through a grassroots teachers body called CAS, Computing at Schools, that really looked at our current ICT curriculum and thought, we've dropped out how computers work. We've dropped out programming, we've dropped out computational thinking. They're sort of not there. So we've got a whole generation of children who are wandering past all of these artifacts, their computers, their iPhones, their tablets, their traffic light systems, everything around them. They just don't really understand how any of this works. Yeah. So we really thought it was important to bring back the sort of essential knowledge back into the curriculum.
Can you briefly explain what computational thinking really is?
Yeah, well, computational thinking is a set of critical thinking skills, and which have been really useful for computing. Jeanette Wing, a computer scientist from America, was the first person to sort of coin the term. And so this involves things like algorithmic thinking, which is about the steps or rules to do something. I mean, algorithms rule our everyday life. We don't realise it. Yeah. Even getting dressed in the morning, we don't randomly put on our clothes. We have an order to things, otherwise our underpants come out the outside. Yeah. We end up looking like Superman. So even at the basic level, algorithms rule everything. And then there's algorithm evaluation, which is about, somehow we might think about different sets of rules or instructions, but which one's the best one? Which one's the most efficient? Which does the best job? I mean, we have things like £1 million prizes for who can pack the best luggage into planes because it will save companies, loads of money on. So algorithms rule everything. And then we've got decomposition, breaking a complex problem up into smaller areas, solving those things separately. We've got generalization, the idea of taking an idea and then adapting and using it for something else. Abstraction, trying to find the sort of key information from something. And then once you've found that key information, you can then often use it to generalize. So, we've got all of these thinking skills, which are all sort of part of logical reasoning as well, thinking something through.
Because many people think, why should every child learn this in primary school? Because programming is often the way to learn it then, the robots. And, why is everyone doing Scratch, for example?
Yeah. I think it's so important to say that the programming is the best way of logically thinking through these things, using the computational thinking in real exciting, fun ways, actually making something. I mean, I'm really pleased to be here today and see lots of people from the maker movement. The fact that making, because actually, if you're just using computational thinking, and you can, without the making, then it's a little bit of a dry, slightly boring thing. And actually, I would hazard a guess that not that many of us would be that interested in this. When you program something, when you create something, you're creating it for other people. You're creating something that you want to get out there and let other people use and see and evaluate and enjoy, and that's all part of this as well. I didn't come up with the smartphone and think, I'm just going to use it for myself, because of course nobody else would have been able to text me or tweet me or anything. So it's about that connected thing as well.
Okay. And in the Netherlands, you see a lot of teachers, maybe the same in the UK, don't feel like they got the competencies to teach in these areas.
I think this is a real issue, because what we've done, because we almost the sort of Microsoftation of education, the let's all learn Excel and Word and Power. And don't get me wrong, there's a place for those in education, but actually, through just concentrating on those things, what we've done is we've dropped out the essential thinking of how some of these things work. So of course we've got a whole generation of teachers who didn't do any of this at school themselves, and I think this is a big education But what I'm finding is when I'm doing work with primary school teachers or secondary school teachers, and I'm starting with the thinking first of all, where they all go, well, actually, I love those thinking skills for my pupils. You know, it's not just about computing. I mean, you know, generalization, decomposition. These are really useful skills across the curriculum as well. And what they really want their pupils to be more than anything is resilient learners. And one of the things that computing science has is this idea of debugging something, fixing a problem, and that it being the student's responsibility to fixing it. So one of the things we've seen in the UK is as we start to concentrate on computing science principles, as we start to do some programming, as we start to put the emphasis back on children solving these problems, then we're removing a lot of the helplessness that sometimes comes in education. Encouraging the child to be the person who's actually solving something. And this is actually making them resilient in other areas as well. So I think as people see the benefits of adding this small strand of understanding the technology around us, then, you know, then they buy in. And that's important.
So what would you advise a school who is thinking of putting these computational thinking skills in the curriculum? How should they start?
Yeah, I think it's worth getting online first of all, and actually understanding the computational thinking first. When I run courses, almost the first bit I do is always talk through the thinking skills. People expect you to go straight into programming. Actually, you know, programming is the lovely vehicle to use to sort of explore
the
those
broader
things.
perspective.
I think that's important. I would certainly join CAS, Computing at Schools. We have a forum that's free. It's designed for UK teachers, but it's very welcome, and so we could share some of our experience of how we've actually rolled that out, and the pitfalls and the things that are worth doing, whether you're talking to governments or whether you're talking to teachers, or, you know, because there are different things that people want to explore. One of the big things for us, is sort of in a governmental terms, was really sort of exploring the fact that actually this is really good knowledge for your workforce to take away and understand, you know, that it's going to help UK PLC. But of course that's a different set of arguments when you're talking to teachers, which is about developing the students' thinking and understanding. And
but I think it's these insights can be very important to us, because in this aspect, UK is ahead of us, and there's many people in the Netherlands also talking about like how we should pay more attention to digital literacy, computational thinking, programming in the basic curriculum. So what lessons can you teach us about this whole process of bringing this in our curriculum?
Yeah, I think what I see sometimes is people always talking about coding and programming, and actually you're far better to focus first of all on the thinking skills. And I think we've sort of said that already, haven't we? And then the benefits of understanding the technology. But I think what we do have an uphill struggle, because what we've got is we've got a whole generation of teachers, politicians, who actually haven't done this themselves. So of course, you know, that's quite an issue to get round, really.
So the experience, bringing the experience to these people.
It's been really nice to host. I've had a couple of Dutch teachers, professional, who have come over and watched some lessons. You know, and I think we need to collaborate and be very open for people to come and. It's not just about talking; it's about seeing something in action. It's quite nice recently. I mean, I have a book out, how to teach primary programming using Scratch. Hopefully, there are some hooks that people can have a look at something like that, read some ideas. You know, I hope people take those ideas and change them, adapt them, make them right for themselves, their students. You know, I see lots and lots of where you give children an opening into understanding this. They go away and they go and change it and adapt it and make it their own, and that is brilliant. That really excites me as a teacher.
Okay, nice. And then for the last question, when are you done? When is your work done? When you're like, okay, now.
I mean, one of the things that got me into this in the first place, because I was I was an advanced skills teacher for ICT, which is our old, and I found that my pupils got to a certain point and there was nothing else that I could stretch them with. You know, we could use lots and lots of great technology in lots and lots of other areas, but there was sort of it wasn't open-ended enough. And one of the things I've really enjoyed with the computing science is that actually it's massively open-ended. And I've seen pupils really go on and stretch themselves to a much, much higher level, sometimes through self-study, through getting an interest in this, and then I've ended up running some lessons where 8, 9 pupils are going off and working on their own projects, doing work at home. I'm teaching maybe the rest of the class. You know, so it's that ability for a struggle. Yeah. Struggle's great. Without any struggle, there's no learning. And
it should be presently frustrating.
Yes. That's the thing which gets pupils going away and looking at this and exploring it themselves, and that attitude, that sort of open mindset of hey, struggle's good. Yeah. You know, okay. And that's I don't know whether that's answered your question or not. I've probably gone off on one, but
no, but I think it's good. Well, what's your struggle now? What are your next challenge?
Yeah, I think the things for me. That's a good question, actually. I feel that I'm actually looking at more the sort of information technology aspect at the moment. So understanding how networks work, understanding the internet, and breaking those concepts and ideas down into ways that children understand. I mean, I had a lovely set of lessons recently where we drew out with chalk on the playground some of how our school network works. So we had and then we sat the children down. We had a child sat there as the server. We had a children sat as computers and laptops and tablets. And then we drew out the routers and off to the internet. And then we set some children up to be the bits of data. So the child sitting on the laptop would say to the child who was a bit of data, go and log on. And that child would take that information to the server and say, here's my name. And they'd say, well, how have you spelt it? And they'd say, this. And they'd say, oh, no, wrong. Oh, you can't log on. The computer says no, you know. And then they'd go back to the server and pick up a piece of information, or they'd go via the routers off into the internet to pick up a web page. And that physical modelling of something, interestingly, they had an after-school club that same day, and the teacher responsible for that, she said the pupils you were working with, they got all of the children to play networks of whatever age, and they were all being the bits of data. And I tend to think, you know, if something like that goes into, so I'm looking for more and more simple ways of explaining, getting children into understanding the things they use. You know, they use the internet probably every day, most of them. But if we don't get what this is and how it works, then we're sort of selling children short, really. So simplification, getting pupils into understanding, that's probably you know, my next sort of challenge. And the challenges of explaining things to teachers and also giving them a bigger mindset of what can be achieved. When a child comes to me, I've had children come to me in year 5, year 6, sorry, that's 10 to 11-year-olds, that sort of age, and say to me, Mr. Bagge, we've been doing squared numbers in maths. Can I write a program to work out squared numbers? Can I? So it's the other challenge is getting people away from always thinking gaming. Yeah. We've seen when I do only gaming computing, then what I tend to see is that my boys are very engaged with this, and my girls are less interested. And interesting, doing a real variety of programming types has brought in a much wider sphere of children. So now I do a strand of maths programming, with a strand of music, a strand of literacy, English languages, and a strand of gaming as well. And it's about seeing that this is a wider thing than just games. And don't get me wrong, I love games.
Me too. Okay, well, thank you very much. I think there's plenty of work to do. Yes. So good luck with that, and see you soon.
Thank you. Thanks very much, Erik. Much appreciated.
Thank you.